Hello everyone, I'm Paul and today we're solving problem 3497, maximum unique subarray sum after deletion. This one is easy and the key here is observation. So next I will show you my thought process and how to solve this efficiently. We are given an integer array nums such as this one. We are allowed to delete any number of elements from this array without making this empty, and after performing all the deletions we need to select a subarray such that all the elements in this subarray are unique and the sum of the elements in the subarray is maximized. Finally, we need to return the maximum sum of this subarray. Now, there are many ways to solve this, and here we show you the most intuitive solution, or at least for me. We need to select a subarray. Remember that a subarray is a contiguous selection of elements. So if this is an array, this is a subarray because this is a contiguous selection of elements. So for example, this is a subarray, this is a subarray, but we can't form a subarray with these and these elements. Now the main observation here is that we can delete any number of elements. And if we can delete any number of elements and we need to select a subarray with unique elements, we can transform this into a set. And in sets we can't have repeated elements. So first we transform this into a set, and now we have this. These three elements are unique. This is the same as if we delete these 20, for example, or these 20. Now we know every number here is unique, so this is okay. And now we need to get the maximum sum for the elements in this set. And the way to get the maximum sum here is, first we take the maximum element, meaning 100, so the result is currently 100, and we remove this from the set. And now we iterate remaining elements and we check what is the largest element among these plus each of these and this. So let's say we are iterating this one first and we check what is the maximum among 100 and 100 plus minus 20, meaning 80. The maximum here is 100, so we keep 100 in the result and we continue. Now we are here and we are checking what is the maximum among 100 and 100 plus 20, meaning 120. The maximum here is this, so now the result is 120. Now we have seen every element in the set and we have the maximum sum, which is 120, so we return this. Now you might be wondering, why are we deciding to start with the maximum element here, with this 100? Why don't we just start with this element, for example? Well, if we start with minus 20 and we remove this from the set, now we do the same. The result is currently minus 20, and the maximum among minus 20 and minus 20 plus 20, meaning 0, is 0. So now the result would be 0. Next we are here. The maximum among 0 and 100 is 100, so the result in this case would be 100. And this is not the maximum sum. The way to make sure that we get the maximum sum is to start with the maximum element in the result. So we start with 100 here. And this is how we finally get the result 120, which is the maximum sum. Now maybe the most tricky part here is to understand why are we choosing the maximum value initially in the result. And the answer is the following. Let's say we are building a tower and we start with one brick. And the most intelligent thing here is if we are trying to build the tower with the maximum height, is to pick the largest brick, which is what we are doing here. And now the tower has this height. Next we receive another brick and we are checking if we add this brick here, will the height of the tower increase or not? And If it does, we add the brick, and if it doesn't, we don't add the brick, because we are trying to get the maximum height. And this is exactly what we are doing here. We start with the largest brick, meaning with the maximum value in this set, and then we are iterating every remaining value, and we are checking if we can make this value larger. And if we can, we increase this value. This is how we get 120. If we start with this brick, we will never be able to get the maximum value. So this is it for the approach. Time and space complexity will be big O of n, because we are building and iterating this set, and we also need the result. So now let's go with the code, and hopefully you will get the idea. First, n is length of nums, and we will transform this array into a set. So we'll call this all, and this is a set from nums. And now we can take the maximum value. This is the maximum in all, and now we can remove from all this maximum value. The result is initially this maximum value. Now we can iterate all, so we say for every value in all, result is the maximum among the result, and result plus value, and finally we return the result. So this is it for the code. This is a short code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.